We're back again with another LeetCode problem. This one is an easy one. Problem 1275. Find winner on Tic Tac Toe Game. Um, let's get started. Gonna get this done in Java. Now I've preloaded a little bit of notes just because this could be a little tricky to explain and write the notes while I'm doing the video. So I hope that doesn't count as cheating. We'll go over this quickly. Tic Tac Toe game is played by two players, A and B, on a 3x3 grid. Obviously, we all know how to play tic-tac-toe. X's and O's. Player A will always go first. Player B is the second. Player A uses X. Player B uses O's. The game ends when there are three non-empty characters filling any row or column. The game also ends if squares are non-empty. And no more moves can be played and the game is over. So the parameters that you're given a 2D integer array, moves, where the moves, the row of the column, indicates that move will be played on the grid, the row in the column. And the goal is to return the winner of the game if it exists, player A or B, in which case the game ends in a draw. If there are movements still to play, return pending. Here's some examples. And then the constraints. There are no repeated elements. So that's good. It means we don't have to do any checks. And they follow the static rules. So for problems like these, what I like to do is build a smallest little visual representation if you need it, just so you can reference it. You can get through the use cases a little bit better. So we're going to need a variable to hold the actual grid, so to hold the representation of this empty board here. So what we're going to do is we're going to create a double character array to do this, a char array. And we're assigning it to size 3 because, as in the problem, it's a 3x3 grid. And we also want to know how many moves we've made. There can only be 3 times 3, 9 moves. So we're going to keep track of that. Put that down here under the notes. That makes sense. And then we want a Boolean to figure out whose turn it is. So is it player A or is it player B? And since player A is always going first, we're just going to automatically assign that to true to begin with. And one interesting thing you can think of here is I put these values in here. So characters, char, it's a character and it also is an ASCII value. So it has an integer value as well as the character. So one way you could handle this if you wanted to was you could look up the ASCII character, X or O. X is equal to 88. So if you were to sum the ASCII value of 3 characters, 88 times 3, you would get 264. That would mean that you have 3 X's in a row, and the same with O. So I'm just putting this here as a different implementation just to keep track of. But we'll just go ahead and fill in the board. So given all the moves, let's just populate the board with all the plays. So we're going to do that with a for loop. For int I equals 0, I is less than moves.length, I plus plus. That way we cycle through all of them. And if you recall, the moves themselves, it's an array of arrays. So we're just going to cycle through and grab the first one, put the first 0, 0, then we'll grab the second one, 2, 0, that's an O, etc. Let's make this easy for ourselves. The row, the moves, 0. And the reason we're doing this, right? The row is the first element here, and the column is here. So 0, 0, boom. Row, column, 0, 1, 2, 0, boom. 1, 1, it should be an X. 0, 1, 1. X, 2, 1. Makes sense. Okay, let's move on. So let's check and see if it's A player's turn. If it's A player's turn, let's do the move. Now, since player A just had their turn, we're gonna change that flag so that it's player B's turn. And we'll also update the moves counter to keep track of how many moves we had, so we can return pending if we need to, or draw. Now, if it's not A player's turn, it's obviously B player's turn. So here, we'll assign their move to O. And we'll flip that toggle for A player's turn and also update the moves counter. So now we've done that. And we want to check now, do we have any winners? And we're going to be doing this inside or after the for loop, because we want to populate the board with all the moves and then figure out if it's pending or if we have a winner or it's a draw. So how do we figure out what is a winner? We have a 3x3 grid and you know what to do with tic-tac-toe. You could do any different way of approaching this, but let's think efficiently. So there are 3 use cases to figure out if it's a success, right? So if a player won, they had to have 3 in a row either diagonally, they'd have 3 in a row either horizontally or vertically. So if we look at this grid, how can we figure out a good diagonal? Diagonals are set, and since it's a 3x3, we could hard code those. So diagonal, that looks like we would have 0, 0. We'd have 1, 1, and then we'd have 2, 2. That would account for 0, 0, 1, 1, 2, 2. Diagonal going from left to right. Now we also want right to left. So right to left, that is this case here. Boom, boom, boom. So that would be 0, 2, 1, 1. And the final 2, 0. And that's because we have 0, 2, 1, 1, 2, 0. That accounts for diagonal. So we'll do this for both of them, right? These are obviously on the board, okay? So hope that goes without saying. And now we have the checking the rows and the columns, because you can also go vertical. You could have X, 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 that wins. You could have X, 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 that wins. And so to check the rows and the columns, we're going to want to do a loop. But let's code the diagonals in here real quick since we've got them. So if board of 0, 0, and we'll do the ASCII here just for example purposes. The board of 0, 0 plus the board of 1, 1 plus the board of 2, 2 equals player A ASCII win value or board of the other diagonal 0, 2 plus board of 1, 1 plus board of 2, 0. Then return A. And what we're doing here, so if the diagonals from left to right, the characters, if their ASCII values add up to equal the ASCII value of 3 times the character, then we know that that person's 1. And if the right to left add up to the same value, we know that person's 1 as well. And then we return A. And so we're going to do this again for the player B diagonal. We'll just adjust this right. We're going to use player B ASCII value. And that works there. Okay. And then we'll return a B here. Use player B1. And now we need to check the rows and columns. So we're going to do that with a loop. Let's do for int k equals 0. K is less than 3, k plus plus. We're going to do 3 iterations because the grid is 3 by 3. So we want to iterate. And we're going to be checking the rows and the columns simultaneously. A nice little tertiary loop here. So if, now for rows and columns, let's think about this. For rows, we would need, if we're looping through, k equals 0, we'd need k, 0. We need k, 1. And we need k, 2. Right? And we also want to make sure, since the character value, the default character value is this escape character. It's like the null. So we want to make sure that it's not a null as well. Okay. And then for columns, we're going to do this all in one loop. We don't want to run extra loops. We want to keep it efficient. For columns, we'll be going for 0, k, 1, k, and 2, k. And make sure it's not null. It's this value here, char, character. And so just if you want to visualize this, right? For rows, if you're iterating, the first iteration is 0. So you want to go 0, 0, 0. You want to check 0, 1. And you want to check 0, 2. And then you're going to check the column. So now you go 0, 0, k is 0. And then you go 1, 0. Then you go 2, 0. And the next iteration, you have k equals 1. So you'll be checking 1 or 1 0, 1 1, 1 2, and then you'll be checking 0 1, 0 2, 0 3. Does that make sense? So let's go ahead and get to that. So if the first element equals the second element and the second element equals, we're going to do a different solution here, not the ASCII, just because I want to switch things up. Show some different ways you can approach this. So here we're going to return if the board k of 0 equals x, then we want to say, yeah, that's player A, he won. Otherwise, player B won. It's a tertiary operator. Look it up if you're not familiar. And then we're going to do the columns. So if all the column elements equal each other and they are not null, then we're going to return the answer. So that covers the columns here. Covers the rows. That's all done inside of this loop. Okay. And now we want to check and see if the we want to check and see if it's pending, and we want to check and see if the game is done. So let's see where we're at. So right here, we'll double check. And remember, we have that move counter. So if it's less than 9, then we know that we have a pending game because there's still a move to be made. The board is not complete. And if it is 9, then we know we finished the game. And so let's double check this. Hopefully I don't have any syntax errors. We've got one somewhere. Line 35. Ah. Yeah, that would be a 0. Looks like I had a little typo here. See? Fine. Return form. So here, looks like we have a little syntax error. Um, oh, I have this right here. This shouldn't be there. And should run. And here, look at this one. Tick, tick, tick. Equals that. Equals this. And looks like I got carried away trying to wrap it up quickly here. $22. Ah, a different variable here. And we got it. All right. Sorry about the hiccups. It's currently midnight, so we're grinding it out. But yeah, that's how to do this problem. I highly recommend visualizing the arrays if you need to. And I hope you have a good time finishing onward with your journey. Good luck.